Hi my dear student, today we will discuss Rene Descartes Rule. Descartes Rule of sign is used to determine the number of real zeros of a polynomial function. Let f of x be the given polynomial of degree n. According to number of sign changes in f of x and f of minus x gives the information about the number of real roots. That is positive root and negative root respectively. Now, number of positive roots. If p is the number of sign changes in f of x, then the number of positive roots may be at most p, p minus 2, p minus 4, etc. 0 or 1. Then there are exactly 0 positive roots or 1 positive roots respectively. In this case, we are reducing the utmost value of p by multiple of 2 we are subtracting. Okay, that's why the utmost number of positive roots be p, p minus 2, p minus 4, etc. or 0 or 1. Note, if no sign changes in p of x, then there is no positive root. Now, number of negative roots. If q is the number of sign changes f of minus x, then the number of negative roots may be at most q or q minus 2 or q minus 4, etc. 0 or 1. Then there are exactly 0 or 1 negative roots respectively. Make a note, if no sign changes in p of minus x, then there is no negative roots. In this case also, the number of roots at most q and reduced by multiple of 2, that is q, q minus 2, q minus 4, or etc. 0 or 1 roots respectively. Now, number of imaginary roots. In this case, number of imaginary roots may be at least n minus of p plus q, where n is the degree of the given polynomial. P and q are the utmost value of positive and negative roots respectively. Simply, Rene Descartes rule explain, if p is the number of sign changes in f of x, then the number of positive roots may be at most p or p minus 2, p minus 4, or etc. 0 or 1 respectively. If q is the number of sign changes in f of minus x, negative roots may be at most q or q minus 2 or q minus 4, etc. 0 or 1 respectively. Is it clear? Now the number of imaginary roots may be calculated by n minus of p plus q at least. That is, in this case the number of imaginary roots may be at least n minus of p plus q, where n is the degree of the polynomial, p and q are the utmost value of the positive and negative roots respectively. Now we will see an example. Example, let us take p of x equal to 5x power 4 plus 10x cube minus x square plus 6x plus 5. In this case, p of x has 2 sign changes. Therefore, p of x has 2 or 0 positive real roots. Now p of minus x, which can be calculated, replace x by minus x. We are getting p of minus x as 5x power 4 minus 10 times x cube minus x square minus 6x plus 5. In this case, p of minus x has 2 sign changes. Therefore, p of x has 2 or 0 negative real roots. Therefore, the number of imaginary roots in this case we will use n minus of p plus q. Here p value is 2 at most and q value at most 2. Therefore, the number of imaginary roots will be 4 or 2 or 0 imaginary roots. In this case, the possible outcomes are: first column represent positive roots, second column represent negative roots, third column represent imaginary roots, and the fourth column total number of roots. So the possible outcomes are 2 positive root, 2 negative roots, 0 imaginary roots. Total is 4. 2 positive root, 0 negative roots, 2 imaginary roots. Therefore, total 4 roots. Or 0 positive roots, 2 negative roots, 2 imaginary roots. Total 4 roots. Or 0 positive roots, 0 negative roots, 4 imaginary roots. Total 4. These are the possible outcomes. By using Descartes' rule, we cannot able to find out the exact number of positive and negative and imaginary roots respectively. So in this case, we can able to find out the number of possible outcomes in this way. Particularly in this example, when you draw the graph, it shows in the figure, it has 2 negative roots and 2 imaginary roots. So this given example has 0 positive roots, 2 negative roots, 2 imaginary roots. By using the graph, we can able to find the exact number 1. But by using Descartes' rule, we can able to find the possible outcomes of the results. Is it clear?